Hello all at the Dataverse community meeting. My name is Janet McDougall, Archive Manager, and I'm introducing the Australian Data Archive on behalf of the ADA team. ADA was established in 1981 with focus on the provision of highly curated, mainly quantitative data in the social sciences. In 2017 we migrated from the Nestar to the Dataverse platform, so we have been part of this great community for a while now and wish we could be here in person. We're based within POLIS, the Centre for Social Research and Methods at the Australian National University in Canberra, Australia's capital territory. See the blue star. Mate Mitrev, developer, will showcase 2 applications we've developed to integrate with the Dataverse platform.
At the Australian Data Archive, we have 2 applications which we have developed in-house, Cadre and Adapt. Cadre, Coordinated Access to Data, Research and Environments, is a decision-making framework implemented as a web application that operationalizes the 5 safes. While the majority of ADA's datasets are accessible via download through its Dataverse instance, ADA is replacing the Dataverse guestbook functionality with Cadre to provide a robust set of decision-making processes and tracking for data requests and approval or rejection. When a set of users are approved for access in Cadre, a Dataverse provisioner component adds the set of users to a pre-existing group in Dataverse that has been configured to provide file download permissions to the requested files. A flow-through from Cadre approval to Dataverse access is automated. For a more complete explanation of Cadre and how ADA has integrated it with Dataverse, those interested can view informational videos on our YouTube channel. The ADA archival processing tool, Adapt, was developed to ensure ADA's archival flows follow formal processes based on the Open Archival Information System, or OAIS reference model. Adapt integrates the OAIS with Dataverse infrastructure via API calls to support the flow of dataset deposits, archivists processing and curation, and data dissemination for secondary use. Adapt implements Prov-O logs to ensure provenance is captured for all Adapt functions. Adapt also provides the capacity for reporting, internal notes, and user management, providing a complete web application experience.
The Harvard Dataverse repository introduced its paid large data services last in 2024. Our large data services are provided by a team of people at IQSS. The service is supported by members from our data curation, finance, software development, and technical support departments. As you are all aware, the last decade has seen increased demand for large data support. Research has become more data and compute intensive. At Harvard Dataverse Repository, we have seen an increased number of requests for these services, including a demand for large data storage, stewardship, and computing. In fact, over the past 5 years, we have received over 120 tickets about large data support. From hospitals, Harvard and non-Harvard researchers, groups, and U.S. government departments, ranging from 1 terabyte to 950 terabytes of storage. Requirements include immediate and individual file access, support for millions of files, collection growth, versioning, restricted content, indefinite retention, and budget-friendly options. When developing sustainable large data services, we identified 3 key challenges and considerations: technical, curatorial, and administrative. Technical limitations on large data storage infrastructures strongly influence how we curate the data itself, particularly how we arrange it and the number of files allowed. Here, we summarize some of the key challenges and considerations. Key issues are sustainability, data storage, access, and file arrangement, speed and type of user interactivity via UI or API, and the cost of storage and upload/downloads. We are fortunate to have access to large data storage options through Harvard's relationship with the Northeast Storage Exchange, NESI. NESI provides low-cost tape and disk access to Northeastern academic institutions with no upload or download charges. We utilize the Dataverse integration with Globus for this support. Although Harvard Dataverse is a self-service repository enabling users to create an account, then deposit and publish their data, our large data service offerings are high touch and require a consultation and payment upfront for storage. We offer services across 3 categories: pre-service support, including consultations, letters of support, and quotes; large data curation services, including free and paid options; and large data storage and access services for AWS S3, Nessie Tape, and Nessie Disk. To make these services sustainable, we require a 6-year commitment paid upfront. This enables us to defray the cost of future collections maintenance while anticipating some reductions in storage costs over time. Next, we will discuss these services and specific use cases in greater detail. All of our documentation, instructions, and intake form are available on our website, support.dataverse.harvard.edu. Hard requirements on data packaging are included in the documentation and in the intake form to ensure the project can be repackaged for the support selected. README documentation is available for both upload and download of data via Globus to the storage infrastructure. We developed our large data use case in collaboration with the Gray Co-Petition utilizing a 12 terabyte project from the Decode Lab at MIT. This document is available in Zenodo. Thank you.
Here are 2 more types of changes that we hope will make data more findable. The first is a change to the Dataverse account page, which lets users add an ORCID to their account. After logging into my Harvard Dataverse account, I can go to my account information page, click Add Authenticated ORCID, log into my ORCID account, and confirm that I want to add my ORCID to my repository account. Then when I create datasets, my name and ORCID are added to the author metadata fields in case I need to include myself as an author. To add an author that's a person, I can search for and select a name from the ORCID API, and Harvard Dataverse includes that person's ORCID in the metadata. To add that person's affiliation, I can search for and select a name from the ROR API, and Harvard Dataverse includes that organization's ROR ID in the metadata. Similarly, to add information about who funded the research that produced this data, I can search for and select a name from ROR. We also changed how this information is displayed on the page to indicate that the information the depositor added about authors and funders includes ORCIDs and RORs. To help us validate our understanding of user needs and behaviors, promote its successes, continue improving the design, and improving other parts of the deposit experience, we're conducting different types of UX research that builds on the work of the UX working group, including usability testing and benchmarking.
Hi, I'm Philip Durbin, a developer for Dataverse, and I'd like to tell you about a new feature called Croissant, a metadata vocabulary for machine learning datasets. Here we see a dataset on our demo site. Croissant appears in 2 places. If I click on metadata and then export metadata, I can see Croissant as one of the options. Croissant is JSON LD based on schema.org. One thing to note is that for files that have been successfully ingested, you can see information about the columns or variables such as description or data type. The second place Croissant appears is in the head of the HTML document. This is for tools like Google Dataset Search to be able to show the world that your dataset supports this new standard. Here we see a link to mlcommons.org where you can learn more about Croissant. The Dataverse community is actively participating in the Croissant working group, and everyone is welcome to join. You're welcome to play around with Croissant on Harvard Dataverse or on our website at demo.dataverse.org.
Thank you for joining us for the Texas Data Repository's annual activity report for the Dataverse Community Meeting 2025. The accomplishments highlighted today are the result of incredible work by the TDR Steering Committee members. The Texas Data Repository is a collaborative effort currently supported by 12 member institutions across the state. Our community continues to grow, strengthening shared infrastructure and practices.
This year, the TDR has seen a number of important developments. First, the Dataverse software was successfully updated to version 6.6, ensuring continued improvements in performance and functionality. We're also engaged in the Core Notify project, which is working to connect data in the TDR with publications in DSpace institutional repositories, strengthening the link between datasets and scholarly communication. A best file formats guide was created and uploaded to our shared wiki in February 2025 to help users better understand how to preserve their research data. We've also produced several instructional videos focused on using the TDR and on research data management best practices. 2 completed videos cover README files and tips for searching the TDR. These are available through our user guide and YouTube playlist. In addition, we develop larger data requirements to support researcher needs. And lastly, the Dataset Retention Group has recommended how to align TDR practices with state and funder expectations for data retention.
Over the past 8 years, the TDR's user base has steadily increased, and we now have over 2,000 registered users. We currently manage more than 3,000 datasets. The majority of these are openly accessible online, supporting transparency and open research. As of March 2025, there are 219 active API tokens in use, supporting integration and automation for about 2,000 users across the platform. Thank you for watching. We are proud of the work being done in the Texas Data Repository and the Dataverse community, and look forward to what's ahead.